Assalamualaikum warahmatullahi wabarakatuh. I'm Faisal Zid bin Abdul Rahim, and this is Mustari. There is Azri, and there is Anim, and also the cameraman is Farizwan. So we cannot go into the same video because the screen is so small. So now that's all. Okay, next. Okay, we will talk about the closed loop system. Okay, for the introduction, loading, sorry. Okay, there is the definition about the closed loop control system. Okay, which is in the definition, okay, a closed loop control system is a system that controls the system by using the output and as the input of the system. So this can be understood as the output will affect the input of the system. So the last one, the output will be used as the feedback to return to input for adjusting the system. Okay, next. Okay, there are four main components in the closed loop system. Okay, which is the controller, actuator, plant or system, and sensor. Okay, the controller used as the machine that produces control signal, while the actuator is a machine that helps to function the parts in the system. And the third one is the plant, or we also call it a system, which is the system to be controlled. And the last one is sensor, which is a machine to detect the change in system. Okay, next.
Yes, Assalamualaikum. This is how do refrigerator works. Okay, for the firstly, refrigerator need an electricity as the input. Okay. Then after from the input, it can transfer to the supply to the controller, which is in this refrigerator, which is switch. From the controller, we can put our desired temperature in it, and we can adjust what we want. From the controller, it will transfer to actuator, which is compressor. From the compressor, we pump the refrigerant and compress it, and refrigerant will flow through the coil on the back or under the refrigerator and through the expansion valve to the inside of the freezer. As the refrigerant pass through the expansion valve, the pressure will drop. Okay. This is for our plant system of the refrigerator. Then after pressure drop, it will continue working, and after suddenly we can see the change of temperature, which is drop or increase, and then the sensor will detect the temperature and can send the feedback back to the controller, and controller will adjust back the desired temperature, and it will rotate the system. Next. Okay, this is for general block diagram. You can see the input controller, and then to the actuator. After the actuator work, it go to plant, and sensor will detect the wrong system and give the feedback to the controller. Okay, this is refrigerator block diagram. For the input, we put it electricity, and then for the controller, which is switch, then the compressor, and then from the compressor, which is actuator, we send the stimulus to the system, and then for the sensor is thermostat. Okay, from the block diagram we can describe the controller. The controller is the part of process that manages of control the entire system of process. The controller in refrigerator is switch. By using this switch, we can set the desired temperature we need. This is image of switch. Okay, for the next diagram is actuator. Actuator also known as a control device. In this refrigerator, actuator is compressor. Okay, compressor pump the refrigerator and compress it. Okay, next. Okay, after the actuator will send the impulse to the plant or system. After the for the plant system, after the signal is corrected by the controller, the signal goes to the process or plant. The example of the component in the system is throttling device, evaporator, compressor, and condenser. For the throttle device, it works as obstruct the flow of liquid or liquid is produced with help of this device. Then evaporator acts as heat absorption process. Then condenser will condense the vapor to liquid and temperature will return to normal level. This is diagram of our system, which is refrigerator system. Then the last one is sensor. Sensor is detector device that detect the output of the system. When we get the undesired output, sensor will detect and send back as the feedback to the controller, and then controller will adjust the input signal back. This is our sensor, which is thermostat. That's all for me.
Okay, next I will continue the presentation with the transfer function. Transfer function that is typical to show the relation between inlet and outlet of the heat exchange in refrigerator is shown by this equation. We name it as equation 1. The application of unit step U as is a typical signal used to analyze this type of system. The Laplace transform for this equation is 1 over S. So this is the next equation. Okay, next. CT response will be obtained by applying partial fraction. We need to do the partial fraction at previous equation. Then and inverse the Laplace transform. Then we get this equation. We name it as equation 3. In converting the gain K, CT will become K in bracket equation 3, where T equal to time constant for the system, K proportional gain of the heat exchanger. Finally, change in the refrigerant mass flow rate that is shown by the behavior of the evaporator at the inlet section. Applying the inverse Laplace transform is equation 5, which is delta T outlet equal to delta T inlet equal to the rest of the equation. With the result of this equation 5 and energy balance, it is possible to calculate the evaporator cooling load. Okay, thanks.
Assalamualaikum warahmatullahi wabarakatuh. I will explain about the discussion how the refrigerator working basic principle. So a colder liquid simply pass continuously around the object. It is to be cooled. The heat will be taken from the object, and as the example shown below, a cold liquid pass over the apple, which is to be cooled. Next, for an air conditioning system to operate the economy, the refrigerator must be respectively. The refrigerator comes into the compressor as low pressure gas. It is compressed and then moved out of the compressor as a high pressure gas. The gas then flow to the condenser. Then the liquid moves to the expansion valve under high pressure. The low pressure liquid then moves to the evaporator, and then the refrigerant moves to the compressor where the entire cycle is repeated. So how the vapor compression cycle? The vapor compression cycle is used in most household refrigerator. Figure 1 shows a schematic diagram of the component of typical vapor compression refrigeration system. In the cycle, circulating refrigerant such as freons enters the compressor as a vapor. The separated vapor travels through the condenser, which first cool and remove the superheat, and then condenses the vapor into a liquid by removing additional heat at constant pressure and temperature. After that, the liquid refrigerant goes through the expansion valve, also called the throttle valve, where its pressure abruptly decreases. Then the cool liquid vapor mixture then travel through the evaporator coil. And lastly, the resulting vapor returns to the compressor inlet to complete the thermodynamic cycle. That's all from me.
Alright, so I continue the presentation with the conclusion. So as a conclusion, closed loop control system can help people to regulate the system condition automatically when they need the system to be changed based on the surrounding. So it's really help people when you have leftover foods or fresh food to be chilled into the refrigerator. And also if we feeling hot in the hot days or hot room, we can turn on the air conditioning to make the surrounding more comfortable. So that's all from our group, and thank you.